Welcome to Microbuilds and happy Thanksgiving. Here's a scope, which I'm also very thankful for. So let's get started so I can explain how to use this thing. Oscilloscopes. The wonderful brick of technology made of steel and silicon components that constantly has to stay grounded and needs to have a differential probe for anything that has any kind of reference to ground or neutral that may or may not be grounded. Intimidating. Well, I'm going to fix that for you. Slap. Anyway, stop being intimidating. You only have like 6 knobs. And some buttons. Yep, that's it. So anyway, if I hook my probe, I'm actually going to start with hooking up the probe here. So I do everything looking through the camera, so it's kind of dumb. Anyway, so if I go and so I'm just gonna put this down a little ways. I'll explain what all these knobs do in a minute. So this is a square wave. You might already know that, which I really hope you do because that will come in handy a lot. 0, 3 volts. 0, 3 volts. 0, 3 volts. 0, 3 volts, 0, 3 volts, 0, 3, 0, 3, 0, 3, 0, 3. You get the idea. So anyway, this happens at 1 kilohertz. The scope over here is telling me I'm using a 10x probe, which I am. You can actually choose what kind of probe you're using. I switched mine to 10x. So that means there's a 9 mega ohm resistors in series with the 1 mega ohm resistor to make 10 mega ohms. So that basically just decreases everything coming into the scope by a factor of 10. Beautiful. So anyway, 5 knobs. So this is your trigger level. So if I don't have this line here, also shown by that tiny arrow when you're not moving it, if I don't have that within the square wave thing, 2 lines and some garbage. But if I just slowly bring it up, slowly, just touch it, right as soon as I touch it. Yep, triggered. Now, to make sure you don't actually bump that knob and untrigger this thing, then put it right there. So anyway, now that we've properly triggered a scope, if I turn off channel 2, and then I turn on channel 1, which is not connected to anything, and I plug in my little dongle thing. Yep, okay. So if I plug that in there, and I increase the volts for division, division is each one of those squares. So if I center that, for instance, and then I set the volts per division to be so say I set each one to be about so it's 2 volts, 3 volts. So now it's 100 millivolts per division. Okay, now it's just toying with me. Oh, don't give me that. So if I set to 200, 100, the amplitude is supposed to be something. Okay. Oh, yep, okay, yeah, sorry. This actually carries me into my next point. Sorry I paused like that. That was super awkward. So I gotta set up my trigger. and I go down here, and we're not on channel 2 anymore. We're on channel 1. So now, if I move the volts per division, 100 millivolts, so 1/10 of a volt. What is it doing? Well, that's super sus. Oh, yes, I forgot. It's because, remember how I said everything's decreased by a factor of 1 millivolt? And I also gotta trigger this better. So remember how I said everything is decreased by a factor of 10 when you're on the 10x setting? So when I set it to, like, 100, oh, sorry, wrong way. If I set this to 100 millivolts, or 1/10 of a volt per division, and this is a 3 volt signal, and everything is decreased by 10, do the math, 3 volts divided by 0.1. Okay, look, you get this. So if I turn on the 1x setting, which gets rid of 9 mega ohms and makes 1 mega ohm, and then I just decrease the volts of divisions, so the volts per division, till it says 1 volt, you might be able to count 3 squares between the top and the bottom of this waveform. So that is beautiful. It's just gorgeous. So now we know that much. Probes, you're welcome. Anyway, so there you go. So that's vertical positioning. That's up and down. That's volts per division, which is what I was just playing with. If I click that knob, perfectly centered on the 0 line. Now, this is horizontal positioning. So, that way. Now, if I click that, then we're perfectly centered there, too. And then you have fine adjustment and coarse adjustment. Just keep it in fine, I guess. Whatever floats your boat. This actually does not have fine or coarse adjustment. This gives you zoom. So notice there's a grayed out area up here, and right under that arrow, there's going to be a little unshaded area that's going to open up. There you go. So what we're looking at there is, notice whatever is inside this square wave, that's what we're seeing down here. So if we increase the volts per division and bring it down some, oh, come on, man. 500 millivolts. Let me just take this down a minute. Oh, chill. There we go. And now we just take it 1 millivolt. So, okay, well, there you go. So now it is 100 millivolts per division, just like before. So everything within there is amplified a long ways. So if we narrow out the section that we're looking at, that little line gets stretched across the entire screen, and we see this. So then if we pull out cursors, it's just a button up there. You click it, and then you get this. And you use your general purpose knob, and you click it, and then you get this knob. Kazam, we put that at the bottom of the waveform. Then we look over here, and then we put that at the top of the waveform, like right as soon as it levels off. And let's see, it is around 4 microseconds. So now that's 4 microseconds. That's how long it took from this square wave to go from 0 to 3 volts. Yeet. Okay, so now we're going to get out of that menu. And, yeah, so that takes care of vertical positioning and zoom and stuff that we don't really care about. Now, 100 kilohertz happens, so that means 1,000 times a second. And there it is in real time. Thank you, roll button. Math and reference are stuff I don't really care about right now and don't know how to use. Single is like the trigger level, but it'll only see what's within 1 second of you triggering it. Measure is for stuff like this. If I click the measure button, it tells you like everything that you would possibly need to know about your waveform. Let's just get rid of that. Navigations is for stuff I haven't used yet. History is if you save anything. Decode is for anything serial that you might need to decode. I'm not sure how to use that. Clear sweeps is if you use the single button, you can either click that again or hit clear sweeps and it'll clear the screen so you can trigger it again. Utility is for something later. Save and recall. That actually, apparently, you're supposed to be able to use a flash drive like this, and you stick it into this USB port. Tells me the USB flash drive is detected. Now, if I click that button, which I'm not gonna because it's a pain in the butt to get back off, it gives you the code that is the equivalent of saying you went from 0 to 3 volts at any given pace, and this is how you remake that on the computer. But I don't really care about that, so what you do instead is you hit and now I have a picture of everything that is on the screen. Not just the box with the waveform, not just the arrows in the waveform. No, everything on the screen. All of it. Just from corner to corner to corner. All of it. Screenshot. And then I can look at that later. I'll delete that later because that's useless. I know what a square wave looks like. But say it was something more complex that I need to analyze later. Then, I mean, like, you're welcome. Now you have a picture. So even this garage door opener, which I'm sure I might like crush something with the garage door if I open it, but I don't know. Anyway, not important. That will actually make a serial thing that I may or may not be able to code with that. Decode with the decode button, which is for I2C and stuff. So, digital is 16 more inputs that you can plug into that HDMI port. No, you cannot put a bigger monitor. It has a caution sign that says S-Bus, so only digital pins, which is activated with this button. And actually, just for experimental purposes, I'm going to turn off channel 1 and turn on the digitals. Yeah, it knows nothing's there. So we're going to bring that back. I don't own the probes for that. I don't need the probes for that. I already have 4 channels and 4 more probes. Way up there. Good enough. So, then there's the default. So if I click that, which I'm not gonna because I have it set how I like, it goes back to a factory reset of the scope how it was originally. Auto setup is like, it sets up the triggering for you and everything. I like doing it by hand because I feel like I know stuff. It makes me feel smart. So the probes say that they're made so you can, it says all inputs must be like above 1 mega ohm through the probe, 15 picofarads as the capacitance. There's a screw on this probe somewhere. That screw does not hold the probe together like you may think, because there's a rod right there and you'd think that holds it in. That is actually a trimmer capacitor, and a trimmer capacitor, which I'll explain in the next video in detail, probably. I don't know. I might have better things to show off. Not show off. I might have better things to explain instead of like twisty capacitors, because I don't own any yet except for the ones that are embedded into my probes already. But 15 picofarads is what they want it set to. 400 volts peak to peak. Yeah, that's basically telling you just don't plug anything over 400 volts into this thing or it'll go boom. Do not probe anything. Do not clip this ground clip to anything that has a reference to ground. So, because these B and C connectors are grounded directly. They don't just go to negative. These are let me show you. So, on this, wow, this is way better acoustics. So this is your live. Sorry, that's your live. That's your neutral, and that's your ground. This ground is the same as the ground coming in there, and all the other outlets in my room. And sorry, I cut that off early. I was saying the ground is common through your entire house and the rest of the world, basically, because it's just stakes driven into the ground. So if you, touch something and it makes a spark, which, by the way, is around 30 kilovolts, it goes through the ground instead of frying your scope. So, also, if you're trying to cheat your way out of an isolation transformer, don't. Either buy a differential probe and, stop being a cheapo, or just don't probe anything that is grounded. And do not remove the ground from your scope, because A, it won't work. Second of all, just why? You won't be able to, probe anything, and you'll fry your scope. It's just bad. Don't do it. I almost made that mistake by wearing one of those 3-to-1, 2 to 3 plugs. And surprise, surprise, you know why they have that little clip hanging out the side? That is strictly there for one reason. That ground clip sticking out the side where the earth pin is supposed to be is telling you, hey, over here, down here, look at the plug, look closer. It's telling you that is supposed to be there. You are supposed to ground whatever you plug in. That is giving you something to put a ground lead on and ground something. The only reason they make 3-to-2 converters is so if you don't necessarily need a ground, or you intend on grounding it some other how, and your outlet only has 2 holes for some strange reason, then you have a way to put that in there. But that's not how it's always going to work, so because you don't just want to use those all willy-nilly, because you might need to ground something. Your scope will end up being grounded either way unless you try to kill it. So anyway, after this rant, do not remove the ground from your scope, and always make sure your scope is properly grounded. You use the included power cord if you have a key, a siglent like I do. Siglent is very particular, and I think somewhere in the specifications it's use our grounded power cord thing if you want to not void your warranty and fry your scope and not get a new one. So yeah, that's how life works. Don't waste your money. These are expensive. You can Google the model number yourself. These are expensive. You don't want to blow these up. These are very nice pieces of lab equipment. Thank you to Siglent for making good products. They didn't sponsor this. Just thank Siglent for making good quality stuff, because in a world where everything's either made in everything's either made out of low quality materials, or people just don't really care what they're doing at this point, you just really gotta be grateful that people like Siglent Company are making really nice oscilloscopes and shipping them, I'm pretty sure, worldwide, where anybody who has the kind of money to get one can get one. And they're just lovely pieces of equipment. I'm not sure if it's comparable, but it's good as, if not, just as good, I guess. It's a good scope. There's not much more to say. It does anything you need, and even as a beginner hobbyist like I am, not really a beginner, I've been doing this for 5 years, but as somebody who loves electronics and hasn't had a scope just recently on November 11th, for someone who has not had a scope, this is just a wonderful piece of lab equipment. Anywhere from beginners to anybody who's older than I am and has been doing this for their entire life would be able to use this scope, and it does everything and more. And if for some strange reason you'd need 4 analogs and happen to need 16 digital pins, you can get that on this scope too. And it's just a beautiful thing that Siglent has created. But again, don't go blowing up your scopes, because it's bad. Anyway, so I want to keep this video under 25 minutes, so yeah. If ever you need reference for how to use an oscilloscope, I hope this video helped a little bit. This is how many volts for division, your vertical positioning, your horizontal positioning, your times, your time increments per division, your navigation keys, some of your utilities, That's your general purpose knob. These buttons down here. That one will save stuff to flash drives. That hides your menu. Those buttons down there is how you'll interact, depending on what is right directly above on the screen of the button is what kind of menu you'll be entering. This is for calibration. If your square wave is looking super wonky, you can turn that trimmer capacitor screw on the side there, and it will clean it up a little bit. It's in the quick start guide. Siglent sends this little quick start guide with your SDS1104X-E. They send that with it so you can get started. It'll tell you just about everything you need to know. And if not, it's very simple. Most scopes are like this. I think the Rigels have their buttons on the side there instead of down there. And then I think some just have a whole bunch of buttons. That's your channels, some other functions. That's all your trigger stuff and your BNC connectors. Then you're all set. Don't probe anything grounded or over 400 volts and you're good. Thank you for watching my builds. Have a wonderful Thanksgiving weekend. And shout out to my 9-ish subscribers, hopefully. I haven't checked recently. Hopefully it's around 9. Just shout out to all the people who support this channel, what little there are, because it's new. But, yeah, that's the oscilloscope. Thanks for watching. Like, subscribe, ring the notifications bell, so if I ever get off time with the schedule of posting things, you'll know when something does come out. And have a wonderful Thanksgiving. This was my Siglent oscilloscope, and thank you for watching.